Welcome back, ladies and gentlemen. In this lesson, what we are going to be doing is the opposite of what the prior lesson was, where what we did is we condensed a logarithm using the properties of logs, meaning if I had two logs of the same base that were added together, well, we could take the material or the components inside of the parentheses and say that those had to be multiplied together, whatever they were. And if we had logs that were of the same base and we were subtracting one from the other, we could take the material inside of the parentheses and say 1 divided by the other one. And that is how, the basics of what we were doing as far as taking a logarithm and condensing it. Well, now what we're going to be doing is kind of the undoing part. We're going to be unraveling a logarithm that is condensed and still using the same properties. Now, what you're seeing here, let's go ahead and fix this. It should actually say 2, and that's 3. Those are kind of the operations or the steps that we're going to be looking at as far as how we're going to do it. Now, the first thing is something that you didn't see when we were condensing, but if I have a radical is something that I'm doing in a logarithm. Okay, well, here, now the a, remember, that has some exponent. So I'm going to just say, I don't know, we'll call it m. Let's say that that has a exponent of m. Well, in this case, m is 1. So let's put that as m. If I want to rewrite a radical number, I can rewrite it as whatever the radicand is. Okay, in this case, a is m over n. This is the index. We would refer to that as an index number. So for instance, if I had, I don't know, the 4th root of 8 cubed, that would be the same thing as saying 8 to the 3/4 power. That's all that is kind of talking about. Now, the one thing I will kind of mention specifically, if I say the square root of some number, the index number on a square root, we don't write it because square roots are the most common type of radical number that we work with. So a square root number, that index is not ever written. It's just written as the square root of x or the square root of whatever. So this has an exponent of 1 and the index is 2. So we would have that as x to the 1/2 power. But just keep in mind, if you see a radical where the index number is not written, because 2 is the most common type of root that we perform, we don't write it because that's the most common one. So anything else, usually the index number is specifically written for you. But for square roots, you have to recognize that the index number will be 2. And so the second thing, separate the individual logs. Okay, so if something is, multiplied together inside of the parentheses, well, that means you could expand it through addition. And if something is divided inside of the parentheses, well, that means you could expand it through subtraction. And if I have anything in an exponent position, I would put it down in front of the coefficients and say, well, it will be multiplied something. So just real quick so we can kind of see what they look like. If let's say I had log of xy, that would be the same thing as saying log of x plus the log of y. If I had log of x over y, that would be the same thing as saying log of x minus the log of y. That's what we would do to kind of undo, to expand it after we've already condensed it. And the last thing that it's telling you here is if I have anything as an exponent, we'll put it as a log. Put it in front of the log as a coefficient. So let's say, if we had log of x cubed, well, that would be the same thing as saying 3 times the log of x. So let's take a look at our examples. Now, I'll be honest, the first example that we see here is going to have the most in the way of things that we have to unravel. when we expand it. And this is going to be the most involved example that you'll see, but if you can follow along with this one, then pretty much everything else that we will do from here on out is going to be pretty basic. So what we see is in the log, in the parentheses, we actually have 3 terms in the numerator that are being multiplied, and in the denominator we have 2 terms that are being multiplied. And excuse me, so what we need to do is we need to separate the numerator and the denominator with some kind of subtraction because they're being divided one to the other. So first step, we'd say log base 7, and I'm going to just take everything in the numerator, the 4, the a, and the b squared, and I'm going to subtract whatever is in the denominator. So I'm going to say minus the log of, oops, not d, let's keep it in the same order, c cubed times d. Okay. Now, in the parentheses on the left and in the parentheses on the right, the 4, the a, the b squared, the c cubed, and the d, all of those things are being multiplied to each other. So because they're being multiplied to each other, that means, well, we can separate each of those terms, the 4, the a, the b squared, we can separate those, we can expand those further with a addition operation. So on the left, we'll have log base 7 still, and I'm going to separate the 4 plus log base 7 with the a plus the log base 7 with the b squared. Now this is where, if you're going to make a mistake, this is where you're going to make it. The c cubed and the d inside of the second log, and I realize I forgot my base here. The c and the d in the inside of the parentheses, the second log, we also are going to separate those with an addition operation. Okay, but I'm subtracting all of that. Okay, so you might want to think about it like this: is if I have, let's put a bracket set of parentheses around this log. What I'm going to do is I'm going to separate those, but I'm subtracting whatever those separate into. So I need to keep all of that in its own set of parentheses to show, just like what we would in a normal algebraic expression, that we're subtracting that whole thing. It's kind of like saying, let's say I had 5 minus x plus 4. Okay? Well, that negative sign has to go to everything inside of the parentheses. So the negative sign that we have in front of the log must also be applied to the c cubed and the d after we kind of break it apart. So I'm going to put a minus sign here, and I'm going to keep everything inside of that in its own parentheses for the time being. So I'm going to say log base 7 of c cubed plus, those are being added together because the c and the d are multiplied, so that if we expand it, it says expand it with a plus sign. So log base 7 of d. Okay, now at this point, if we want to, we can distribute the negative sign into the parentheses, but we'll kind of do this all together at one go. So again, I need to keep the c and the d logs in their own parentheses, because at some point after we expand it, if you just put the minus sign here without the parentheses between the c and the d logs, then the only thing that will be wind up negative is the c term, and we're really applying that subtraction operation, that negative sign, to both the c and the d. That's why I need to keep it in the parentheses for the time being. So log base 7 of 4, well, there's nothing else going on here, so log base 7 of 4. The log base 7 of a still is just, oops, I want to write the big 7 here. Let me fix that. So here I'm going to say log base 7 of a plus, now here I have the b has an exponent on it. So the last thing that we saw on the previous screen says, okay, anything with an exponent, right, as a coefficient. So log base 7 of b squared becomes 2 times log by 7 of b. Okay, now I'm going to go ahead and distribute the negative into the parentheses, and I'm also going to take care of the exponent on the c at the same time. So the negative to the log base 7 of c cubed will make the whole thing negative, and the 3 in the exponent comes down as a coefficient, so I have a negative 3 log base 7 of c, and there are no exponents that we need to worry about on the d term, but we did distribute the negative sign into the parentheses, so I'm going to say minus log base 7 of d, and that whole enchilada is your answer. So there we go. That is the final unraveled or uncondensed or expanded, whichever adjective you prefer. That's the final answer for this expression. And again, there were several things that we had to pay attention to. So we initially started by taking the numerator and the denominator and separating those with a subtraction operation. Then inside of each set of parentheses, expanding those out through addition operations, keeping in mind that the C and D need to be in their own parentheses because that's like we're subtracting an expression, so the negative has to be applied to both of them. And then finally, the third thing is to any exponents that we had, we wrote it in a coefficient position with the 2 and the 3. And of course, we distributed the negative into the parentheses with the C and the D logs to wind up at our final answer right here. So let's try another one. This is going to be another one that until you do a couple of them, but after you really do just a couple, you'll be pretty okay with them. Here we have log of the cubed root of 34. Now 34 isn't something that I could just like take the cubed root of and simplify it that way. Okay, so keep in mind we have n radical x to the m power, which is the same thing as saying x to the m over n power. So what we need to do is convert the radical into an exponent. So what I would do, the 34 itself has an exponent of 1. So when I convert the radical into an exponent, I'm going to get 34 to the 1/3 power. Now we're not, there's no other logs here, meaning that we didn't have to undo anything that was being multiplied or divided. And so we don't really have anything else to expand here. The only thing that we have left is what the third step of that first screen said, which was, well, if I have something as an exponent, which I do right here, take it and write it as a coefficient of the log. So I'm going to have 1/3 times the log of 34, and that is all we can do on that one to expand it. And we're not really expanding it, we're kind of just rewriting it from a radical into, you know, just a normal exponent and log thing. So here is our second to last example. No big deal. In fact, a lot of you are probably going to look at this and say, well, hey, what can I simplify? There really isn't anything else going on here. And this one is a little bit of a tricky one because the 121 is a perfect square. It is the same thing as saying 11 squared. So what they're hoping that you'll start recognizing, log base 7 of 121 is the same thing as saying log base 7 of 11 squared. And just like we saw in the last example, if I have something in an exponent position, like I have the 2 now, I will write it by placing that in the coefficient position. So I'd say 2 times log base 7 of 11. And that one seems kind of a stretch as far as, well, why would I want to do that? Why would I want to just leave it as 121? But you get the idea that, well, 121 can be rewritten as 11 squared, so technically they are the same thing, although I don't think too many people would really give you a hard time if you did math with that. But anyway, we'll go ahead and say, well, we'll do it the way the curriculum asks us to and simplify it as 2 log base 7 of 11. So last one, again, not too much in the way of expanding here. We're not having some log and in the parentheses of the log saying something multiplied by something or something divided by something. So we're not going to expand anything through addition or subtraction like we did in the first example. But we do have an exponent. We do have the 3x plus 2, and in this case, because it is an expression, we treat that slightly differently than we did with the 2 that we did in the previous example and the 1/3 exponent that we did a couple of problems ago. So here, if I take the expression and I put it in the coefficient spot, this is an expression, so I need to keep it in parentheses. So I'm going to say 3x plus 2 in parentheses times the natural log of 10. Now, this is slightly unique in the fact that, well, the 10 actually is kind of being applied to both the 3x and the 2. So we think of this as, well, let's distribute the 10 into the parentheses, and, pardon me, that would give me 3 x times the natural log of 10 plus 2 times the natural log of 10. And that would really be what our final expanded form would be in an example such as this. So final wrap-up thoughts here are just, again, if you are trying to expand a logarithm, anything inside of the parentheses, separate it by, like if something is multiplied in parentheses, separate it through addition, divide it in parentheses, separate it through subtraction, and anything that's in an exponent spot, rewrite it by putting it in the coefficient, and that would be the final expanded logarithm. So again, any questions that you might have as you were watching the video, please make sure you write them down and bring them to me when you see me in class or in tutoring. I will be more than happy to help you, and I look forward to seeing all of you soon. So thanks for watching, and good luck. See you around.